In this sequence of videos, we are going to be talking about the Rubik's Cube. Although don't get too excited, we're going to focus on the smallest version of the Rubik's Cube that's at least a little bit interesting, which is called the pocket cube. So the pocket cube might also be called a 2x2 Rubik's Cube. And even though the standard Rubik's Cube was invented first in 1977, after that proved to be a challenge for some to solve, the pocket cube was debuted in 1983 in order to help people get a feel for that larger Rubik's Cube. And despite the fact that it seems very small and very innocuous, there are actually about 3.5 million configurations of this cube, so quite a bit of possibility and quite a bit of difficulty packed into just this small cube. And there's some really awesome mathematics behind a Rubik's Cube that we are going to be investigating just a little bit of today, and it's in a field called abstract algebra, which is very near and dear to my heart. Despite the fact that there are some 3.5 million configurations of this pocket cube, they all come about from what are 6 basic movements of this cube. And we are going to have a little bit of notation and convention as to how we envision holding this cube and making movements on this cube. So we are going to talk about single turns of each of the 6 faces of the Rubik's Cube. And when we think about turning them, we're always going to think about turning them in a clockwise direction. But there's a little bit of confusion here because we're going to be talking about clockwise as if you were looking at that face. So in particular, if you're thinking about the cube facing you and you've got a front face and a back face, what would be a clockwise turn if you were looking at the back face would be a counterclockwise turn as viewed from the front of that cube. So you've got to be a little bit careful in terms of thinking about that there. And we are going to make abbreviations for a single face based on where it's located on the cube as we imagine holding it. So we're going to have the front face with an F, the back face with a B, the left face with an L, the right face with an R, and because we have a little bit of a conflict with back and bottom, we're not going to refer to the top and the bottom of the cube, but sort of the up of the cube and the down of the cube for what would more naturally be called the top and the bottom. But that gives us this D and B differentiation between back and bottom. Now it is true that we could talk about all motions on this pocket cube as clockwise turns of these faces or combinations thereof. However, it's sometimes convenient, instead of thinking about rotating a face 3 times clockwise, to think about rotating it once counterclockwise. And so we want to introduce that notation. And what we're going to do when we indicate that a face is being turned counterclockwise as opposed to clockwise by convention is we'll put these little apostrophes after each of the different face names, and I'm going to actually refer to them as primes. So I'm going to say out loud F primed to mean turn that face counterclockwise. Now when we start talking about combining movements of these different faces, I've got a little bit of a fuzzy picture here for you, but it will do. We're going to combine them left to right just like we would be reading. And that might seem normal and natural to you, but can sometimes cause confusion because we're going to talk about how many of these motions of the Rubik's Cube can be thought of as functions. And function composition we tend to read sort of inside out, which would be thought of as kind of a right to left. So just so you are aware, in this video, we're going to think about if I see R primed, U primed, to be thought of as first taking the cube and rotating the right face counterclockwise, and after that, taking the upper face and rotating it counterclockwise. So that's the convention that we're going to follow there. And I want us to now speak for a moment about how we are going to represent these motions of the cube alternatively. When we're holding a cube and we're manipulating it, we want to think about what am I turning? What physical actions am I doing? But it can be useful in understanding what's going on with the cube to think of it in a different way. And in fact, we'll have a couple of different ways of thinking about and talking about movements on a Rubik's Cube. But one thing we could do is go across all of the stickers on the Rubik's Cube and put numbers on those stickers so that we can track where each sticker goes. So the convention I'm going to use for putting those numbers onto the Rubik's Cube, and this is much more my individual notation and not necessarily standard notation across people who work with Rubik's Cubes frequently, is I'm going to start with a face. I'm going to start in the northeast corner and I'm going to put the smallest number there, and then I'm going to proceed clockwise around that face until I run out of room. So you can see 1, 2, 3, 4. Again, I'm going to use that convention of clockwise being interpreted as though I'm looking at the cube. So where that gets confusing is up here on that back face, I'm using the 9 in the northeast where that direction is being interpreted as though I were looking at that face, and then moving in a clockwise direction, which looks counterclockwise as I'm doing it right now, but would be clockwise from the perspective of the back of the cube. And the order in which I've placed my numbers on my cube is first the front, then the right, then the back, then the left, and then the top and bottom, or up and down as we're referring to them for distinction. So I provided this key right here to let you know what all of my numbers are, but that's the general philosophy of how I came up with that numbering scheme. And once we do this, once we introduce this numbering scheme, we could make a very large table that keeps track of, once a motion is performed, where does each sticker in this starting location move to? So if I were doing a frontwise, clockwise rotation, we see that the 1 would move to the 2's spot, the 2 would move to the 3's spot, the 3 would move to the 4 spot, and the 4 would move to the 1 spot. And so 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 1. And you'll notice that these 5 and 6 aren't affected by a clockwise turn of the front space, so I just indicate that 5 maps to 5. It doesn't go anywhere by repeating that number. The other numbers that move would be the numerical values on the other sides of these stickers. The 18 goes to the 7 space, the 8 goes underneath and maps to the 21st space, and so on.